Hello and welcome to this video on calculation of bond energies. The question has been taken from April 2007 paper 3-1. Question number 7. Hydrogen reacts with halogens to form hydrogen halides. A. Bond energy is the amount of energy in kilojoules that must be supplied to break 1 mole of a bond. There is a table given to you where the bond energies for the respective molecules have been shown. Use the above data to show that the following reaction is exothermic. Now they are asking us to show whether the following reaction, that is the overall reaction, is exothermic or endothermic. Now before you start solving this, it's very important to know what happens when bonds are broken. As you can see, I have circled the H2 and Cl2 molecules. The reason is because in this case bonds are broken. So this is the example of bond breaking. And whenever bonds are broken, energy is supplied to break the bonds, so it is an endothermic reaction. So bond breaking is always an example of an endothermic reaction. So what is happening on the left hand side? There is a endothermic reaction happening on the left hand side, and on the right hand side, if you can see, new bonds are being formed. So bonds are being formed, so bond formation is happening, and whenever new bonds are formed, energy is given out, and therefore the reaction is said to be an exothermic reaction. So clearly for the equation there are two parts. The place where the reactants are present is the example of bond breaking, because first the reactants have to break the bonds within themselves, and therefore energy has to be supplied to break the bonds, and that's an example of endothermic. On the right hand side, that is the product side, new bonds are being formed, and therefore energy is given out when the bonds are formed. So now another thing to remember is, if bonds are being formed and the reaction therefore is exothermic, so the values of bond energy will be in negative. So it exactly tells you that when bonds are being broken, it's an example of endothermic reaction, and therefore for an endothermic reaction the bond energy values will be positive. So now keeping this in mind, let's begin solving the question. Therefore, when 1 mole of H and H bonds are broken, the amount of energy supplied is plus 436 kilojoules, and when 1 mole of ClCl bonds are broken, the amount of energy supplied is 242 kilojoules. Now let's add the amount of energy supplied, and that is equal to 678 kilojoules. Now let's calculate the amount of energy that is released when bonds are broken. Because when products are formed, like I told you, bonds are made, and bond making is exothermic, and all the values of exothermic will be in negative. So when the products are formed from 1 mole of hydrogen and 1 mole of chlorine, 2 moles of hydrogen chloride or hydrochloric acid are formed. So in that case, we will have to multiply the bond energy value by 2. So we have 2 into 431, and that gives you 862 kilojoules per mole. So now, as I told you, the bond energy value will be negative because bonds are being made. So because energy is being released. So on the left hand side, you have plus 678 that was supplied, and on the right hand side, you have minus 862 kilojoules that was given away. So now we need to add the two values of the bond energies. The overall energy change after adding the endothermic and the exothermic reactions is plus 678 minus 862. which gives you minus 184 kilojoules. If you see, after adding the exothermic and the endothermic changes in the reaction, the final value of the energy comes out to be a negative value. So negative value means the amount of energy given out was more than the amount of energy taken in, and therefore we state that the reaction between H2 plus Cl2 to give you 2HCl is an exothermic reaction. So that's all in today's video on calculation of bond energies. I hope you like watching my video. Do subscribe to keep yourself updated with more videos. Thank you.